Hi everyone, I'm M.Yogadharani, working as assistant professor at the Department of Computer Science and Engineering at SLS College of Technology. Why we are gathered here is going to case study on autoencoders and its features. So start this session with a short intro of yours.
So, hello, myself Akshya. We are from third year CSC. Dinesh, Ariswan, Mahalakshmi, and Keshika. We are here to present a case study on how cloud AI system like Microsoft Azure AI use autoencoder for intelligent image compression. So, in modern application, as we all know, huge volume of image data are generated, like healthcare. In healthcare, we see MRI, CT scan, and satellite images, social media platform. So sorting these data in cloud system is costly and require high bandwidth for transformation. So traditional compression technique like JPEG may reduce size, but they often lose important details. So to overcome these, we use autoencoder in deep learning model that learn data pattern automatically, compress image efficiently, and reconstruct them with minimal losses. Let's see an architecture in an overview. Like encoder compress the input, bottleneck store compressed data, then decoder reconstruct the image. This may autoencode be ideal for cloud-based AI system. So the compressing of large data, like large data, and work it in a bottleneck and reconstruct the input, which produce the input similar to the output.
Okay, as Akshay said about CNN architecture and the applications of autoencoder, can anyone tell what is autoencoder?
Autoencoder is a neural network used to learn compressed representation. We have three types: sparse autoencoder, variational autoencoder, denoising autoencoder. Encoder means compressed data. Decoder means reconstructed data.
Can anyone tell what are the feature learning in this case study?
Autoencoders perform feature learning, which means they automatically identify the important characteristics of the data. Unlike the traditional system, we don't manually data features. The encoder learns edges and contours, and colors and textures, object shapes, and noise rather than data. For example, in medical images, highlight the tumors and facial identify the facial features. Work well with the large dataset. Additionally, learning help in the image denoising, pattern recognition, and pre-processing the other AI models. This makes the autoencoder highly efficient in real-world AI applications.
Main purpose of autoencoder is dimensionality reduction. Is any use of dimensionality reduction in this case study?
Ma'am, let me explain about it. Dimensionality reduction and representation learning. Here, autoencoders are widely used for dimensionality reduction and high dimensional data like images contains thousands of pixels, but not all are important. Autoencoders compress data into a small form called latent space. Example like input like 1024 pixels, and here output will be converted like 64 features, and this reduces the storage requirements, computation time, and this leads to representation learning. And here the model learns a meaningful representation of data, and similar to images are grouped together. And the major benefit of this is faster searching and retrieval, better clustering, and improved performance in classification tasks. And it cloud AI system, this helps like optimizing storage, speed up processing, reduces latency. And when this autoencoders makes data more efficient and usable.
Can anyone tell what are the layers, what is the layer size and depth, and what are the effects of the layer?
Effective of layer size and depth extender. The effectiveness of autoencoder depends on layer size and network depth. Layer size and bottleneck layer. They have two types: smaller size and larger size. Smaller size can be high compression but risk of information loss. Larger size can be better reconstruction but less compression. Depth of network. Shallow autoencoders learn simple patterns faster but less powerful. Deep autoencoders learn complex patterns, capture hierarchical features. Example: first layer, middle layer, deep layer. First layer can be edges, middle layer can be shapes, deep layer can be full objects. Challenges: overall fitting, increases training time, need for powerful GPUs. Solution: use regularization, proper tuning of layers, use proper techniques. The deep architecture significantly improve performance, the scale of health.
Okay, in autoencoders, there are nearly 4 to 5 types of autoencoders are there. Which type of autoencoders used in your case study?
Stochastic autoencoder in a real world example, we use the advance of autoencoder or stochastic encoder and decoder, especially variational autoencoder VAE. Instead, on the fixed output, they are learn probability distributions, mean and variable, random sample. Next, this improve the generations and robustness and availability of generation new data. Advantage of stochastic models, better handling of noise data, smooth latent space, next useful in generating tasks. Real world application in cloud AI. Imagine compression in cloud storage, next medical diagnosis systems, image generations and enhancement.
Okay, can anyone conclude this case study?
So, ma'am, in conclusion, autoencoder play a crucial role in modern cloud AI system, such as Microsoft Azure AI, by enabling the efficient image compression while improvising the important features. So they achieve these through feature learning, dimensional reduction, representation learning. So this performance of autoencoder is influenced by the layer size, depth, where deeper models can capture complex data and improvise the accuracy. Additional advanced technique like stochastic encoder and decoders enhance the robustness, allows the better generalization. So overall, deep autoencoder significantly improve the data representation, reduce storage cost, and then enhance the process efficiently, making them easier in real-world application such as image compression, medical analysis, and intelligent cloud-based system.
Well said, Akshay. You've done a great job as you take a 5 part of this case study as CNN architecture and future learning, and somebody tell about what are the effect of layer size and depth, and overall the autoencoders types, and you use a stochastic encoder in this case, right? So good, well done job. Thank you, everybody.
Thank you.